In this video, I am going to discuss an integration technique which will result to trigonometric substitution. Okay, so integrals by trigonometric substitution. If the integrand contains an expression of the form square root of a square minus u square, uh, square root of a square plus u square, or square root of u square minus a square, where a is greater than 0, it is often possible to perform the integration by making a trigonometric substitution, which results in an integral involving trigonometric functions. Okay. So, there are three cases involved here. The first case is when the integrand contains an expression of the form square root of a square minus u square, where a is equal to 0. So, the technique is to introduce a new variable theta by letting u equal to a sine theta. So, let's have a simple illustration. Evaluate the integral of dx all over x squared times square root of 4 minus x squared. Now, the integrand or this integral cannot be solved using the change of variable na technique. So, this is in the form square root of a square minus u square, where a is equal to 2 because 4 is equal to 2 square. So our a is 2 and our u is simply x. So the substitution is let u be equal to a sine theta. So x being our u and a is 2, 2 square. Let x be equal to 2 sine theta. And to differentiate, dx is equal to 2 cosine theta d theta. So from this one, sine theta is equal to x over 2. And so let's construct a triangle. So we have this right triangle. From trigonometry, if this is our theta, then sine is opposite over hypotenuse. So opposite is x and hypotenuse is 2. So the adjacent side is square root of 2 squared minus x squared, or square root of 4 minus x squared. So to get cosine theta, let's have this. Cosine theta is square root of 4 minus x squared over 2 adjacent over hypotenuse. So to cross multiply, square root of 4 minus x squared is simply 2 cosine theta. So with this, let's substitute. Let's replace dx by 2 cosine theta d theta. Let's replace x squared by this. Since x is 2 sine theta, then x squared will be 2 sine theta quantity squared. And then square root of 4 minus x squared is equal to this one, 2 cosine theta. This is the result. Dx to cosine theta, this one is x squared, and then square root of 4 minus x squared is 2 cosine theta. And we'll cancel factors. 2 cosine theta and 2 cosine theta canceled out. So ang result is 2 square 4. So 1/4 sine squared theta. But sine squared theta is what the reciprocal of sine? Cosecant. So this will result to this 1/4 integral of cosecant squared theta d theta. Now this one is a standard form. Integral of cosecant squared theta is negative cotangent. So the result is this. 1/4 times negative cotangent theta plus C. But what is cotangent theta? Cotangent is adjacent over opposite, no? Since it is the reciprocal of tangent. So from the triangle, adjacent over opposite, cotangent theta is square root of 4 minus x squared over x. So you substitute this one, and the final answer is this. Negative 1 over 4x times square root of 4 minus x squared plus c. Okay. And also, as such a trigonometric substitution, you can solve this one using uh, the topic we have discussed, inverse trigonometric function. Same lang sila. Pero sa inverse trigonometric functions, all you have to do is to memorize the form. Oh, you should memorize the form. Pero case to case to. I mean, there are problems na medyo complicated, so much better to use trigonometric substitution. Mas easier siya use. Okay. Another one. Evaluate the integral of dx over x times square root of 25 minus x squared. So 25 is 5 squared. So our a is equal to 5 and then our u is simply x. Substitution is let x be equal to 5 and then sine theta, or u equal to a sine theta. And then you differentiate, and then sine theta, express sine theta equal to x over 5, and then construct a triangle. This is for beginners, but if you are familiar, if you're already familiar with this technique, you may not include this one. Pag familiar na, pero for beginners, this can be your guide. So this one being your theta, sine is opposite over hypotenuse, so x and 5. So the adjacent side is square root of 25 minus x squared. So cosine theta, square root of 25 minus x squared over hypotenuse 5, and then cross multiply, we have this. And then let's substitute dx replaced by this 5 cosine theta d theta, x replaced by 5 sin theta, and square root of 25 minus x squared replaced by 5 cosine theta. This is the result. Okay. So 5 cosine theta will be cancelled. So what is left is 1/5 integral of d theta over sine theta, which is 1 over sine is cosecant. And this is a standard form. Integral of cosecant theta is simply ln of cosecant minus cotangent. This one. Okay. So, what is cosecant? Cosecant is the reciprocal of sine. And sine is opposite over hypotenuse. Therefore, cosecant theta is hypotenuse over opposite. So from this triangle, cosecant theta is hypotenuse over opposite. That's 5 over x. While cotangent, being the reciprocal of tangent, is equal to adjacent over opposite. Because tangent is opposite over adjacent. Opposite over adjacent. So cotangent being the reciprocal is adjacent over opposite. This one. Cotangent theta is square root of 25 minus x squared all over x. And we're going to substitute this one there. Uh, So 1/5 times ln of 5 over x minus square root of 25 minus x squared all over x plus c. And final step is to combine these two terms. And this is the result. 1/5 times ln of 5 minus square root of 25 minus x squared all over x plus c. Okay, so that's it for case number 1. Thank you for watching.